example of adding to
base B numbers, like adding and multiplying?
Yes.
Okay.
Because I'm still having trouble.
Okay. So let's say that we want to add, so pick a base, doesn't matter.
6.
So base 6. So if it's base 6, what are the numbers going to have to be? What are the symbols that you would use for base 6? 0 through 5, right? So let's do, say, 4, 0, and 5, and let's add this to a 2, 5, and 4 in base 6. And so when we add, the main thing that we do is, like, when you add, you're talking about groups and carrying. Everything has to be thought of as groups of 6. So if we had 5 plus 4 is 9. But what is 9 in base 6? So if we have 9 objects in base 10, what would that be in base 6? That'd be one group of 6 and 3, right? That's where we're always going to be in our head having to think. It's like, all right, how many of the groups? And so what you would do is you put a 3 down here, and we have a grouping up above. Now what's 1 plus 0 plus 5? 6. But how do I write 6 in base 6? 1 comma 0, right? So if I had a 6 in base 10, that would actually be just 1, 0 in base 6. Don't read that as the word 10. That's 1, 0. So I have another grouping of 6 with no left over. Now what is 1 plus 4 plus 2? 7. How do I write 7 in base 6? 1, 1. And so this is 1, 1. And so that is all base 6. So in our head, you're constantly doing this. What does this actually represent in the base that I'm doing? It's just, you do multiplications, how many groups of whatever base that I'm dealing with. So addition is just straightforward carry. It's the same thing you do in base 10, except you're putting thought into it. It's one of the reasons why we make, this is one of the things that you would say, that if you're going to teach arithmetic in terms of multiplication with the carry method and addition and things like that, you ought to work in different bases, because guess what? It puts it into your mind what you actually do strongly, so that when you teach it to a kid who's base 10, you just don't, do this, and you put the number here. Why are you doing that? I don't know. That's what I always did. Like, what do these numbers represent? They're positional numbers. What is going on, right? You think about things like this. And so if I would do a multiplication, let's do the same thing. Let's say 4, 0, 5 in base 6, and let's multiply this by 2, 3 in base 6, and then multiply it. Now what if we would do, say, 1, 2, 3 in base 10 and multiply this by 2, 4 in base 10, right? Let's do a base 10 and ask what we do, and then we're going to replicate the same thing in base 6. Okay, how would I multiply this? I take 4 and I multiply across each of those. Why? Because this is distribution, right? 24 is actually 20 plus 4, and 123 is 100 plus 20 plus 3. By the rules of distribution, 20 has to multiply the 100 and the 20 and the 3, and the 4 has to multiply the 100, the 20, and the 3 by distribution. We just keep track of that in terms of position. So we distribute. This is going to be 4 times 3, 4 times 20, 4 times 100. What's 4 times 3? 12. What's 12 in base 10? It's 1 and 2, right? And so we put a 2 here, we put a 1 here, and that 1 is what does that 1 actually represent? I have a group of 10, right? Now, what's 4 times 2? 8, but what really is it? It's 8e, right? But I don't have to worry about the fact that it's 80 because it's in the tens position anyways. So I can use the position to suck up the 0, and so 4 times 2 is 8, but I already had, so I have 8 groups of 10, I have one other group of 10, so I actually have what? 9. With no carries. And what's 4 times 1? That's just simply 4. And so that's 492, 10. So what is this? What is 492? That is actually, what's 492? That is 4 distributed through 100 plus 20 plus 3. I just did that entire distribution in one line. And now I'm going to take 20 and distribute, so I just go ahead and put a 0 there. Why do I put a 0 there? Because I just take care of the position and just treat it as a 2. What's 2 times 3? 6, and base 10 is just 6. What's 2 times 2? 4, and that's just in base 10, so it's just a 4. What's 2 times 1? 2. So really what happened? 20 times 123 is 2,460. It's distribution. I just did distribution, and then all I have to do is, okay, why do we add? Why, when you do stack multiplication, where does this addition come from? Right? Because it's 20 plus 4, right? It's distribution. We're just do one distribution, stack it on a single row, do another distribution, stack it on a single row, and eventually we have to add everything. And so now we just do a normal addition as if it's above. And so this is a 2. What is 9 plus 6? 15, but 15 is a 5 with a group of 10. And that is 9, and that is 2. Does everybody see what I did in base 10? Now let's do the entire thing in base 6. What's 3 times 5? 15. But what is 15 in base 6? How many groups of 6 are in 15?
2.
There's 2 of them. So there's 2 groups of 6, which is 12. So what would be left over? 3. Then what's 3 times 0? 0 plus 2. So I still have my 2 groups of 6. And then what's 3 times 4? 12. And what is 12 in base 6? 2 groups of 6 and then nothing. So what is this 2023 base 6? It is 3 times 405 in base 6. It's distribution. And I get rid of this 2 because it was part of the previous problem. So I'll just get rid of it. Now I'm going to take the 2 and distribute it, but it's actually not 2. It's actually 2, 0. So let's go ahead and put the 0 to take care of the 0. What is 2 times 5? 10. But what's 10 base 6? 1, 4. So that's 1 and a 4. What's 2 times 0? And with the 1 is 1. And what's 2 times 4? 8. And what is 8 in base 6? 1 and 2. And now what do? We add, because this is distribution. We need to add up everybody. What's 3 plus 0? Still 3. What is 2 plus 4? 6, which is a carry 1, put a 0. What's 1 plus 1? 2. 2 plus 2? 4. And then my 1. That's in base 6. Notice it's very algorithmic. If you look at this problem, it's very algorithmic. But if I ask you, does this make any number sense to you? In other words, do you know how big this is? If I said you had 1, 4, 2, 0, 3 in base 6, how much stuff do you have? Is that a lot? Is that a little? I have no idea because I haven't named it in a thing that makes sense to me. I can do all the algorithm, but it's separated from what's commonly used to connect name with quantity for our culture. Is everybody okay with that? How could I turn that into base 10? This 3 is in the what position? Ones. This 0 is in the 6s. This 2 is in the 6 squared, or 36. This is in the 6 cubed, and this is into the 6 to the 4th. So we'd have to find every one of those numbers, multiplied by 1, 4, 2, 0, 3, add it all up, and that would be base 10. Yes, sir?
So, 4 plus 2 is base 6. Like we thought to carry over. So,
The 4 plus 2, where? What? I don't...
when you're adding it on the base 7, 2, and 4.
There's... Oh, these? Yeah, 2 and 4 is 6. And 6 is one group of 6 with nothing left over. It's 1, 0. What's 7 in base 7? 1, 0. What's 11 in base 11? 1, 0. Right? If you're in your base, you have a group of your base and no units left over. So you could easily turn this into base 10 by just doing a little bit of arithmetic. And we need to be able to go both ways, and you need to be able to do the operation.